Welcome back. Today we're going to discuss the time value of money, and in particular we're going to talk about present value and future value. And this is the core of finance. How do you make investments, and under what decisions would you make those investments? So how much money are you going to have in the future if you make an investment today, or if you're going to receive some money in the future, or some payment in the future, or some stream of payments in the future? What are those worth today? So basically the core of what we're going to talk about is how do we calculate values in the future. Maybe you could ask yourself, how much do I need for retirement, for example? That's a future value problem. Or you may have purchased an annuity and you're going to get a fixed stream of payments, and you may want to ask yourself, what is that worth today? So what would I pay today? A present value problem for some future stream of cash flows, or for one payment of a cash flow. Or if somebody says, well, what is $10,000 worth 5 years from now? Well, you can calculate that after we go through this lesson. So I'm going to start off today with my set of notes, which you can find on Blackboard. And I'm going to talk first about future value. And I'm going to scroll here to my notes. And you can see here, you're going to see this denoted in many different ways, but the future value is here denoted as FV equal to, and I'm just using a P. Doesn't matter what we use, you can put present value there, whatever, but it's just some beginning amount, times 1 plus some interest factor raised to the nth power. And so what you have here is you have the future value is equal to the present value, or some current price, or whatever it is, times 1 plus some interest rate raised to the nth power, and the n being how many periods you make the investment over. So if it's one period, the n becomes 1, and this simply becomes the future value is equal to the present value times 1 plus I, which makes sense. For example, if the present value is $100 and the interest rate is 10%, then 100 times 1.10 would be $110 being the future value. So over the course of a year of investment at 10% interest, my investment would increase in value from $100 to $110. And that's why I usually start with future value, because it's really easy for people to understand. So let's look over at Open Office real fast, and I'll show you a quick example just in here. So let's say again that we have the present value, and we're going to allow that to be in this cell. And again, let's just say that it is 100, and we're going to have what is the future value, and we'll just allow it to be over here just for simplicity's sake. And we'll allow the timing of the investment, or the length of the investment, to be in this case 1, and we need the interest rate, and we'll allow that to be 10%. Okay, so again, remember, it's the present value times 1 plus the interest rate raised to the nth power. So I'm going to program that in here. So B4 times 1 plus B3 raised to the B2 power. Let me put my equal sign in here. And there we go. So the value of the investment, make this a little bigger for you, call this bigger. The value of the investment is $110. So you can see that if we start with $100 and we invest it over 1 year, at the end of that year, at 1 year at 10%, at the end of that year the value is going to be 110. So what would it be if we have 2 years? Well, let's just put a 2 in. 2. 121. Why is it 120? Well, if you think about it, we're going to earn $10 over the first year, and over the second year, that $10 that we've earned in interest over the first year is also going to earn interest. So we'll have the $10 from the first year, the $10 we're going to earn over the second year, plus we have a $1 differential, being the $10 we earned in the first year, also earning 10% interest. So we'll have $121. This is compounding, and the longer you have the investment, the more compounding you're going to have. So if you come out 30 years you'll see these values are going to grow. The compounding is going to grow. So the longer the investment, the more compounding you're going to get. And again, this is how you would do it in, if you did it in formulas. That we also have, as I discussed in the Open Office introductory video. Remember, you could come in here and go to Insert Function, right? Insert Functions, and then go to Financial, and come down, and we're looking for, I went too far, Future Value, and see what we need. Rate being the I, which is the interest rate, the N per being N, the payment, which is 0 in this case, we're not adding anything to this investment, the present value being the current present value, and the type. I'm going to discuss that in a little while. For right now, ignore that. So if we come over and link to the rate and the number of periods, and the payment is 0, I'm just going to type a 0 in, and the present value is 100, we're going to find that the result is the same that we had before, 174494. It's exactly the same. So let's just put OK, just so you could see it, right? And we're going to discuss in a little while why this comes back, why this actually comes back negative when you do it in the calculator. Let me come back to that. I'm going to discuss that in a little while. We're going to look at calculators in a few minutes. But so for right now, you can see that these are the same. So if I come in and type 5, they're both going to change to be the same thing. This is, this value is just the same as that, except it's coming back negative. Also, you may use or have a financial calculator, and if you're a finance student, you will. And remember, you can use this time value money calcs website. Click your calculator. You could click Excel. When you're using Open Office, the commands are very similar. And here you see the calculator keystroke N is N per. The calculator keystroke for I is the rate. The calculator keystroke for present value is the same as Excel present value, and the rest are actually the same. Payment, future value, future value. The only ones that are different are these two. But you can also see that it's here. This is what we just did. You can see the future value of a lump sum, and you can see what you can type in. It's exactly the same as what we just did in Open Office. It's this command, future value, and you link to the variables that you need. So don't forget that. But what I have pulled up is just a little financial calculator on a web page. This is exactly what your financial calculator is going to look like. You're going to have the present value, the future value, the N being the number of payments, the payment amount, and the interest rate. And if we just look at our example, I typed it in here earlier. We have present value of 1,000. The interest rate is 10%. The number of payments is 1, and the future value is 1,100. And you see that's negative. Again, I'm going to talk about that. So if we come back and we just type 1 in here, and we type 1,000, you'll see that this is exactly the same as you get. This is exactly the same as you get in the financial calculator, and this is just the inverse of that. So let's talk real fast about why you're getting the negative here. Well, when your calculator solves this, it's assuming that one of these two is an inflow and one's an outflow. So in this case, it's assuming that you're going to invest 1,000 and get 1,100 back. Or you could easily make this negative, and this becomes positive. So basically, your calculator just has to make the assumption that one of these is an inflow and one of these is an outflow. Because your calculator can't say, oh, well, we're going to get $1,000 today, and we're also going to receive $1,100 next year. It just doesn't make any sense. So one of these has to be negative. And so again, if you use the calculator, you're going to see that. So just be aware of that. That this is going to give you the opposite sign of what you may expect sometimes, particularly if you put the investment in as 1,000. But really, in actuality, you're going to invest 1,000, which will be negative, and you're going to receive at the end of the investment $1,100 bucks. Okay, so that is just a quick introduction to future value. And again, the future value equals the present value times 1 plus the interest rate raised to the nth power, where n representing the number of periods for the investment and I representing the interest rate. And here are 6 examples. So if we just want to put these examples into, for example, we can come over back to OpenOffice, and I'm going to try to pull these up beside each other. Give me a second, sorry about that. So if I pull these over and look at them, let's look at the first one. So n in this case is 10. I is also 10%. Present value is 1,000. And what did I get as a future value? Well, 2593.74. It's exactly the same that I got here. And another way to think about this is, if I invest $1,000 at 10% for 10 years, it's going to be worth $2,593.73. And let's just do one more. Let's do this one. So if we come up and we say n is 12, and then I is 3%, and the present value is 3,000, we can see that the future value of that investment is 4,277.28. Now what this future value problems here are assuming is that we have no payment. We're not adding anything to the investment. We're making a one lump sum investment of $1,000 in this case, $2,000 in this case, $3,000 in this case, and we're not adding anything to the investment. It's just a one-time investment. That's future value. That I'm going to post some examples later of future values with an annuity where you add to the investment, like a retirement plan. So every year I'm going to put $1,000 in. What am I going to have at the end of the investment horizon? And so actually I'm going to wrap up, and I'm going to create another little short video to discuss present value, and check that out on Blackboard.